Welcome again, everyone, in the class of the CBS Academy, and we are continuously going to cover the Unit 1, the fundamentals of environmental science. In the last class, we have already covered about in the last few classes, we have already covered about the lithosphere, we already covered the hydrosphere, and we already covered the atmosphere. Currently, we are studying the meteorological factors. And in meteorological factors, we were discussing in last class about the primary winds, the permanent winds, and I have told you that you have to only remember this particular diagram that currently you are seeing on your screen. For remembering the primary winds, their particular characters and from which direction they are coming from. In the study of winds, always remember that whenever you are reading any wind and if you are reading any direction, that direction is telling about from which side the wind is coming. The direction, it is not telling from where the wind is going or for what direction it is going. It is always for from which direction the wind is coming. If wind is coming from the eastern side, we will say this is easterly wind or this is east wind. If wind is coming from the west side, we would say this is west wind or westerly wind. So same concept is used here in the classification of primary winds or permanent winds. The trade winds are basically easterly winds, tropical easterly winds mainly, because you can find out in the tropical region, and these are coming from the eastern direction. But these are used primarily by the ancient people to travel from one place to another place when they are moving through the ship in the large oceans. So they use these winds to move from one continent to another continent. That's why the name is used as trade winds. For the trading purpose, these winds are used. But basically, the nature of trade winds are easterly in direction. And because these are found primarily in the tropical region, so these are the tropical easterlies. Then we have the westerlies, and then we have the polar easterlies. And how to remember the direction and all the things? By remembering this particular diagram. Just make a diagram of the earth, and here you have to just do the one thing. First thing, the wind would be firstly coming from the horse latitude towards the tropical side that you can see here, right, in this direction. And according to the Coriolis force, you have to move these winds. That's all you have to do. So this is the direction in the southern hemisphere. So in the southern hemisphere, we know that due to the Coriolis force, the wind is deflected towards the left side. So the winds are deflected in the left side. And in the northern hemisphere, opposite would be true. In the right side, the winds are deflected in the case of northern hemisphere. So if I face on this particular side in the southern side, so my right would be on this particular side. So these are reflected in these sides. And these would be called as tropical easterlies or trade winds because these are coming from the eastern side and going towards the west side. This is the east and this is the west. This is north, we already know. This is the south pole that we already know. Then the opposite arrow you have to make when you are crossing once the horse latitude. The wind direction would be now opposite. This would be south to north in the northern hemisphere, north to south in the southern hemisphere. And again, the deflection you have to create according to the Coriolis force in the northern hemisphere, right side deflection in the southern hemisphere, face opposite and their left side deflection. And then again, one time again opposite you have to do for the polar easterlies, and you will easily get the direction of the winds by remembering this particular diagram. That's all you have to do when you are remembering the primary winds. And all the characters and everything we have already covered in the last lecture. Today we are starting the secondary winds, which are also called as seasonal or local winds. So here you can see that there are three main types of seasonal or local winds you can find out. One is the monsoonal winds. Monsoonal winds, monsoon name is coming from that type of wind which is seasonal in nature, or this is local in nature. So every year at a particular time period or at a particular season, you are going to face these monsoonal winds. That's why the name is monsoon here. Monsoon is coming from the Mosim word. Mosim word is meaning basically weather. Due to the weather, due to season, the winds are coming. These are the monsoonal winds. Then we have another type, that is the land and sea bridge. And another type we have the mountain and valley bridge. One by one, we will cover all these winds today in the secondary wind classes. So let's go to the slide of the secondary winds directly, because primary winds we have already completed in the last class. Now, Secondary winds, monsoonal winds, you all know. Monsoonal winds are created due to the pressure difference between the land and ocean. So land is generally having less specific heat than the oceanic water, and that's why the heating process would be very high in the case of land surface, while that would be not true for the oceanic surface. Oceanic surfaces are having water is having very high specific heat, and in the case of this high specific heat character, there would be less frequent cooling as well as heating of the oceans as compared to the land surface. So that's why on this summer period, the land is heated very quickly, and the water is not that much heated in the summer season. This is cooled. And due to this particular temperature difference, pressure difference is created. Here, a low pressure would be created, and in the oceanic zone, high pressure would be created. So when there would be high pressure and there would be low pressure, automatically the land warm air will go towards the seaside, and the seaside colder air will come towards the land side. And this sea air is containing huge amount of moisture in it or cloud in it. So that come in the form of monsoon. That is the basic idea of the monsoon and what is the monsoonal winds. That is created due to the temperature difference and pressure difference between the land surface and ocean surface. That's all you have to remember in the case of monsoonal wind. The other winds that we have to discuss is valley wind and mountain, or this is also called as valley bridge or mountain bridge. Bridges are the winds, you can say, or the air currents, you can say. So what is the valley wind and mountain wind? So again, the same phenomena will take place also here. That is the creation of the temperature difference, and due to the temperature difference, there would be creation of the pressure difference. So here you can see during the daytime, this is the sun, and the sun is continuously radiating its energy, and you can see that this is the mountainous range, but the sun's light is directly in the mountain slope. And due to the high amount of this particular sun rays which is falling on the mountain slope, the heating of this mountain is very quick as compared to the valley region. In valley region, this is now cooled down, and because the mountain is facing direct sunlight, so this is heated up during the daytime as compared to the valley. So now here again temperature difference is created, and now temperature difference is created. So what will happen? This warm air will go upside, and the cool air which is in the valley, that will go towards the mountain side. Why? Because of the differential heating of the sun in the valley region and in the mountain region. So here you can see the wind of valley is going towards the mountain side during the daytime. So that's why the wind is coming from the valley region and going towards the mountainous region. So we can say that the wind is valley wind. So it blows from the valley base to the upslope of the mountain, and it occurs only during the daytime. Why? Because of the differential heating of the sunlight. And the overheating of the mountain takes place during the daytime, which ultimately induces the movement of air from this valley region to the mountainous region. Also remember that there is another name of the valley wind that is called as the anabatic wind. So this can be also asked in the examination. So if you upside down this V, this would be something like this. And this is similar to A. That's why, or that's how you can remember the valley wind is associated with the anabatic name or anabatic wind name. So this is also called as anabatic wind or anabatic bridge. This is all about the valley wind, how it takes place. Coming to the next type of wind, that is the mountain winds. Mountain winds would be true in the case of cool night. So what will happen now? You can see that sun is already passed away, and now moon is in the sky. It means this is the night time. Now the same opposite phenomena will take place. Now again, this mountain range is exposed to the air and exposed to the environment more as compared to this valley region. So again, the cooling would be very rapid in the mountainous slope region. If cooling is rapid, so the air which is adjacent to this particular mountains, that is cooled down now. And if it is cooled down, so the warm air now which is present in the valley region, that will go on the upside and the opposite side. And this cool air will go to the downside. Why? Because of the density difference that we have already seen. Because the warm air is less denser and cool air is more denser. So this will come to the valley side from the mountain side. So now this time wind is coming from the mountain side. So this time we will name it as a mountain winds. So blow from the mountain upslope to the base or towards the valley side. And it only occurs during the night time, not during the daytime. And cooling of air close to slope takes place here in this particular phenomena. And this is opposite of the anabatic wind. So this is called as the katabatic winds. So mountain winds are also called as katabatic winds or katabatic bridge or mountain bridge, you can say. So this is the first type of secondary winds that you have to cover, that is the valley wind and the mountain wind. Another type of secondary wind that we have to cover, that is the land bridge and sea bridge. Let's see to that. So now again same phenomena will take place similar to the monsoon. Here during the daytime the sun is exposed here. If sun is present here, so this sun will heat up the land very quickly as compared to the sea. And here there would be low type of pressure would be formed here because of the warm air. And here the sea is not hot that much. This is cool down. And this is cool down. On that scenario, what will take place here? The warm air will go to the upside and the cooler air will fill that place which is coming from the seaside. So this would be called as sea bridge because this is coming from the seaside. So during the daytime, more so in summer, land is heated more than the adjacent body of water. Why? Because of the specific heat of water is very high as compared to the land. So the resistance to temperature is very high in the case of water as compared to land. If resistance to temperature change is high, so it is not going to very quickly heat it up as well as not going to very quickly cool down as well. So as a result, warmed air over the land expands, producing an area of low pressure here. The isobaric surface bend upwards as a result of which the cooler air starts moving from the seaside across the coastline from the sea to land side. This is called as the sea bridge, or this is also called as shore bridge because it is coming from the shore region or the kinara of the ocean, you can say. So it is coming from that side, shore area. So it is also called as the shore wind or sea wind, or sea bridge or shore bridge. Then we have another type of phenomena here which takes place during the night time. So now sun is not there. So obviously the ocean is warmer now and the land will cool down rapidly because again region is the same due to the specific heat. So again the phenomena would be opposite here. Now the cold breeze of this land will go towards the seaside and the warm air of the seaside will come towards the land side. So at night, because of the nocturnal radiation, land is colder than the adjacent sea, and the pressure gradient is directed from the land to sea. Nocturnal radiation means that radiation which is taking place during the night time. Nocturnal means night. So the land is continuously emitting its radiation very quickly, and that's why the temperature is reduced very quickly on the land side, and which creates the temperature difference. And ultimately, this will lead to the pressure difference as well. So there is a gentle flow of wind from the land towards the seaside. This is called as offshore. From the shore, it is going away. Wind, or it is also called as the land wind or land bridge. Now, this is used predominantly by the fishermen. So they used to go on the ocean side during late night or during very early morning at 2 a.m. or 3 a.m. Why? Because at that time they have the support of the land bridge. So with the help of this land bridge, they take their ships towards the deep ocean. And again, at the same time, during the daytime, at 12 noon or 1 o'clock noon, on that time, they again, with the help of the cool sea breeze, they will go back to the shore side or to the land side with the help of this particular sea bridge. So this is the phenomena of sea bridge or land bridge that is part of the secondary wind. So this is all about the secondary winds.